Good morning, this is Kasturi De. Now I'll discuss the language of chemistry chapter according to ICSE syllabus class 8. I'll start today with the writing, how to write a chemical formula of a compound. Okay, so we know that all compounds, they have a chemical formula. So how to write them down? While writing a chemical formula of a chemical compound, it is noted that it is always electrically neutral, that is a balanced positive and negative charges. Okay, the valencies they are balanced. Okay, the how much positive valency is there, that much of negative valency will be present in the chemical formula which will make a chemical compound neutral. Okay, then to write a formula, we need to follow the following steps. First is, we need to write the symbol of the positive ion or the radical to the left and the negative ion or the radical to the right. Okay, so positive will be on the left, positive ion or radical, and negative ion or radical will be on the right. Now, they should be represented by a symbol. Okay, both the ion or radical, that has to be represented by a symbol. Then we need to put the valency number of each of the radicals or ions on its top right. On the top right hand corner of the radical or the ion, whether it is on the left or on the right, we need to write the valency number on the top right hand corner. Okay, then the valency number is divided by the highest common factor, if any, to obtain a simple ratio. If the valency number has to be divided by the HCF. We have studied in the lower classes this HCF, that is highest common factor, if any, to obtain a simple ratio. Then ignoring the positive and the negative symbols of the valency numbers of the radicals are interchanged. Valency numbers are interchanged, ignoring the positive and the negative sign. Then the valency number of the ion or the radical is shifted to the lower right. First, when we were writing in the ionic form or the radical form, the valency number was written at the top right corner, and now after interchanging their positions, we will write them to the lower right hand corner. Okay, if the radical receives a number more than 1, then it is closed within brackets. Okay, single atom is not enclosed within the brackets. Next is, for example, see, in magnesium chloride, if the compound is named as magnesium chloride, so we need to first write the symbol. On the left hand side is the metallic symbol, it will be there, and on the right hand side it will be non-metallic symbols. So first is magnesium, that is Mg, its symbol, and chlorine, Cl. Okay, now the valency numbers, the valency of these positive ion and the negative ion. So valency is, for this positive ion, that is metallic ion or positive ion, that is magnesium, that has been written, see, 2. The 2 is written on the right hand corner of the positive ion, and for the negative ion also, that is also written on the right hand corner as 1, because chlorine has a valency 1 and magnesium has a valency 2. Now interchanging their valency number. Okay, now we interchange the valency number, that is magnesium 2 and chlorine 1. Just cross it. Okay, then writing the interchanged number at the base, we will write in the lower corner, lower right hand corner. See, Mg1 and Cl2 it becomes. Now after interchanging the numbers at the base, we will write the formula as MgCl2. Note that the number 1 with magnesium is not written in the formula because the symbol itself represents 1 atom. That's why 1 is not written inside the formula. Okay. Next example is calcium oxide. For this, the symbols are Ca, that is positive ion, that is metallic ion, and for the non-metallic ion or negative ion, it is oxide, that is O. Now valencies, calcium, it is 2, and oxide, it is also 2. So that has been written like, see, Ca2, upper right hand corner, and oxygen also, it's written 2, that is upper right hand corner. Now interchanging the valencies, it will become Ca, and this 2 will be crust. So both are having the same valency. So reducing the valency number, that is dividing the valency number by HCF, highest common factor, that will be 2. So the lower, that is to make the valency numbers to the lower ratio if it is possible. So it is possible, and that's why it is divided by 2. Highest common factor is 2, so it's divided and it becomes 1. So the formula will become what? CaO. Okay, that is having the same valency. That's why it is becoming CaO. Now for zinc hydroxide, the symbols are zinc and OH. Here also the valency for zinc is 2 and for hydroxide it's 1. So the top right hand corner we are writing, see, Zn2 OH1, and again we are interchanging the valencies. It becomes Zn1 OH2. So the formula will be Zn1 and OH2. Now ignoring the base of the Zn as it is 0, the formula becomes ZnOH whole twice, because 2 of the there is OH radical, okay, that has the total OH radical will have the valency as 2. Okay. Now the ammonium sulfate also NH4. Okay, ammonium radical is NH4 and sulfate is SO4. Ammonium has a valency 1 and sulfate has a valency 2. Again, see, we write the valencies as NH4 1 as the upper corner and SO4 whole twice. That is also written as upper right hand corner, the valency. Then we again interchange it and it becomes NH4 whole twice and SO4 whole 1. So the formula we write is NH4 whole twice SO4 SO4. Okay, so ignoring the base, we will write it as the formula is NH4 whole twice SO4. Next is significance of the molecular or chemical formula. What is the importance of this chemical formula? Okay, molecular or chemical formula. The molecular formula of a compound saves time, space, and energy. It represents one molecule of a compound. The molecule which we write the molecular formula, that represents only one molecule of a compound. Okay, it also represents the number of each kind of atom present, that is the ratio in which the atoms are present in one molecule. In how many ratios they are present in one molecule or in one molecule. Okay, how the compounds which are present inside it, okay, the atoms which are present in the one molecule, how in what ratio they are present, that is represented by a chemical or molecular formula. Now for this, the mass of one molecule of a compound can be calculated if the atomic mass of each element present in the molecule is known. If we know the atoms which are present in the molecule, we know their atomic masses, then we can find out the mass of one molecule of that compound. Molecular mass is the algebraic sum of the masses of all the atoms present in the given molecule. So what is molecular mass? It is the algebraic sum of all the atoms which are present, their mass, that is atomic masses of all the atomic masses. When we sum it, when we sum all the add all the atomic masses of the molecule, that is atomic masses which are present in that molecule, we get the molecular mass. Okay, for example, a molecule of sulfur dioxide is represented by the formula SO2. The element present in it are sulfur and oxygen. So one molecule of sulfur dioxide will consist of one atom of sulfur and two atoms of oxygen. Okay. Now, the molecular mass of sulfur dioxide is obtained by adding the masses of each atom of sulfur and oxygen. So, it is found that atomic mass of sulfur is 32 mu and oxygen is 16 AMU. So, molecular mass will become 32 plus, as it is one atom of sulfur, therefore 32 into 1, that is 32. And for oxygen, it is 2 atoms of oxygen, therefore 16 into 2, that is 32. So that will become to 64 AMU. So the molecular mass of sulfur dioxide is 64 AMU, that is atomic mass unit. Okay. Next is, note the atomic mass is equal to the atomic mass of an atom. Okay. So as mass is very small, as atom is very small, it is not possible to measure its mass in grams. Okay, we cannot measure the mass of an atom in grams because atom is very small. Therefore, mass of a light atom, that is one atom of hydrogen, or 1/12 of the mass of carbon, okay, or 1/16 of the mass of oxygen, is taken as the standard unit with which the mass of an atom of any other element is compared. Okay, so as the one atom's mass is, one atom is very small, so its mass is also very small, and therefore it cannot be calculated in grams. So what happens? We compare this with another light atom. For example, see, one atom of hydrogen, or it is compared to 1/12 of the mass of a carbon, or 1/16 of the mass of an oxygen. Okay, that is considered as the standard unit. Okay, now carbon is generally used for comparison. So this is the atomic mass unit, or AMU. So atomic mass is also known as relative atomic mass, since it is determined for an atom by comparing it with a standard unit. As we find out atomic mass by comparing it with a standard unit, so that's why it can also be called as a relative atomic mass. Okay, it can be a whole number or fraction, as it is the average mass taken from the different isotopes of an element compared to the standard unit. For example, the atomic mass of sodium is 22.99, which is taken to be as 23. Okay, so I'll stop here. I'll continue with the rest of the chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box. I'll try to explain you as much as I can. Okay, and hope you are liking the videos. Press the like button, share with your friends, and also do subscribe to get the notification of my next video. Okay, thank you for watching, and have a good day.